Alright everyone, welcome back to the day 40 of our daily leetcode challenge, and today we have got count number of bad pairs. So let's try to understand the question. In this question they have provided us with an array called nums, and we need to find all such pairs of I and j, such that j minus I is not equal to nums j minus nums I. So the indexes difference is not equal to the value at those indexes difference basically. So this is a j and this is a I. This is what they want us to find, all those pairs of j and I, and here j will always be greater than I, meaning if you have an I at this index, you can only consider j's which are greater than this value at I right here, all those j's which are appearing after this I. Or let's say we have an I here, that would mean all the j's that we can consider for a particular, for pairing with this I, will be only after this I right here. All the j's that are appearing after this I, only those j's will be considered, meaning let's say we have a much longer list here, and all those j's that we have here, they will be compared with this I to find if j minus I is not equal to the value at this j and the value at this I. Let's say we have a 10 here and 3 here. So this index right here is right now 0, 1, 2, 3, 4, 5, 6 and 7. So at index 7 we have the value 10, and at index 3 we have this value that we are considering I here is index 2, we have a value 3. So now we need to find out if this j and this I are satisfying this condition, meaning the index difference should not be equal to the value at those indexes difference. So if this is true, you'll see 5 is not equal to 7. Since 5 is not equal to 7, meaning this j and I is a particular pair, or you could say this pair 2, 7 is a valid pair. We can count this as a bad pair. So this is I and this is j. So this is how the pairing is going to form. Every I that you take, the I is going to range from here, and then it will keep moving forward, but the j will always start with an I plus 1. So that's what I wanted to clarify. Like if let's say I have a I, let's say at index 10, then all the valid j's that we're going to pair with 10 will be always greater than 10, because j is greater than I, they have mentioned clearly. So we'll only consider the j values which are appearing in the array after this value 10. So let's say I am taking a particular value in the array called 10, and I have values like 20, 1, 2, 3. So these values will be getting paired with this 10 one by one, and then we'll be finding if any of those such pairs are bad pairs, meaning the index difference is not equal to the value difference. So this is what a bad pair is. Now let's try to understand this equation from a maths perspective. I'm going to write this equation down and see what we can do with this equation from a perspective of a maths, like how we can kind of modify this equation to help us better solve this problem. So they have clearly mentioned here a bad pair of I and j is called a bad pair if j minus I is not equal to the value at those indexes difference, nums j and minus nums I. So basically this means that the difference of the indexes j and I, and here j is greater than I, as we discussed, j is greater than I, it will always be greater than I if it's a pair. So j is greater than I, and what they mean by a bad pair is the indexes difference should not be equal to the value at those indexes. The indexes difference should not be equal to the difference between the value at those indexes. So if this is a bad pair, then we can conclude from this equation that if this is a bad pair, meaning if this is a bad pair, that would mean at all those pairs I and j where j minus I is equal to the difference between the value at those indexes, meaning is equal to the nums j minus nums I. Then what are these pairs? If this is a bad pair, this would mean that when the cases where they are equal to are nothing but the good pairs. These are the good pairs. So if I tell you, like, to imagine an example of a good pair example could look something like this. I have an array in which I have values like 0, 1, 2, 3, 4, or let's take the second example, because second example has all good pairs. 2, that is why we have 0 bad pairs. 3, 4, 5. Alright, and let me write the indexes as well. 0, 1, 2, 3, 4. You take any two indexes I and j, provided that j is greater than I. That's the condition that you have to follow. J is greater than I. You take any of those indexes. Let's take 1 and 3. Alright, we have 1 and 3 and 4 and 2 in the values. The indexes difference will be 3 minus 1, and the values at those indexes difference. The value at those indexes and their difference, meaning 4 minus 2, will always be equal. 2 is equal to 2. Will always be equal. You take any pairs. You take any pair of j and I. Let's take I am taking I here and j here. 4 and 0. Let's do the same thing. So 4 minus 0 and 5 minus 1. It will always be equal. So this means that in this array particular 1, 2, 3, 4, 5, they are all good pairs. So since we kind of flipped this equation, right, we now didn't flip it, we just converted this not equal to obtain that these are the pairs which are good pairs. So this is the condition of good pairs. So let's now kind of do a deep dive on this equation and see if we can modify it further. So far what we have is j minus I should be equal to nums j minus nums I. This is the condition of a good pair. Now let's try to modify this equation. We can use simple algebra and kind of come to a conclusion that if j minus nums, let me transfer this to this side of this equation. Let me try and also transfer this I to this side of this equation. So if we do that, this is a positive here, this will turn to a negative. So this becomes j minus nums j is equal to I minus nums I. We just transform this equation. So j minus nums j is equal to I minus nums I. Now we can kind of work with this. We can work with this equation right here to find all those good pairs. Now let's discuss how we can do that. So what I mean by here is, we will every time we iterate, right? Every time we iterate, what we're gonna do is we're gonna find the j minus nums j. So let me take the previous example, which was 1, 2, 3, 4, 5. So this is the modified equation now. We started with this equation of not equal to, converted it to a equal to find the condition for good pairs, and then later modified that equation to this equation. J minus nums j is equal to I minus nums I. So let's try to apply this equation now on the second example, which is 1, 2, 3, 4 and 5. Now what we need to do is we need to find all those pairings of j and I, or you could say I and j, where this particular equation is satisfied. J minus num j is equal to I minus nums I. So if you take a look, let's take this example. We are starting with index 0, 0, 1, 2, 3, 4. We are at index 0. Let me perform this part of this equation. Let's take this as the I. This is our I value going forward. Alright, so let's perform this part of this equation now. I minus nums I. What will that be? I minus nums I will be 0 minus 1, which is minus 1. And then we'll store this in the hash map. This minus 1 that we found right now, let me store it in the hash map and update its count to a 1. Alright, now we move to the next value, which is 1. This one right here. Now I shifts from this side to this side. Now we'll do the same thing, I minus the value at this index. So that will be 1 minus 2, which is minus 1. Now we need to check, do we have a minus 1 in the hash map? Yes, we do. We do have a minus 1 in the hash map. And what is the count of that minus 1 which is already present in the hash map, which is 1. Now if you take a look, this minus 1 that we found here can be paired with this minus 1 that we already have in the hash map, right? Because this is the first place, this is the first index where we found a minus 1. For this pair we found a minus 1, and then again we found the same thing on this pair. So if we imagine this as a j, we can say that this j can be paired with this I, since the minus 1 values are same on both ends. So basically this condition getting satisfied. So now that we also have to make a store of a kind of make a variable called count, and its value will be 0 initially. So now since we know that the minus 1 is already present in the hash map, so this would mean that this minus 1 can be paired with this minus 1 that is present in the hash map. So what would be the number of pairs that will be forming? It will always be the current count of that minus 1 in the hash map. So with this minus 1 coming now, we need to check what is the count of this minus 1 in the hash map. It is 1. So that would be the number of pairs that will be forming with this minus 1 that we got now. Initially we started with an empty hash map. first time when we were at this index, we got a -1, we put it in the hash map in the hopes that if we get another -1, what we'll do is we'll pair that -1 with this -1, and it will lead to us one single pair, because because if we have a and b, two values, this is a single pair, right? And let's say we so this is a single pair. So initially in the hash map, count of a was 1, so this a and this a is a single pair, right? But initially in the hash map, the count, when we first encounter an a, the hash map was empty, we put an a value to a 1, then we found another a. Now this a will be pairing with this one. Now how many pairs is going to form? This to know how many pairs this new a is going to form with this one will be nothing but the current count of this a, right, that we have in the hash map, which is 1. So we add that, so this becomes 1 now, and so currently we are gonna have one single pair with this new a coming in, and that is why we are gonna update the count with the current value of whatever a is in the hash map, which is 1. So this count gets updated with a +1. Now since we have one more a, this hash map count has to be increased from 1 to 2. So let's say in further down the line we found another a. So what would this mean? Now this a is going to form two pairs with the current pairs of a that we have. This a is going to form two pairs with these a's that we have. Why? Because if you see, this a gets paired with this, and then this a gets paired with this as well. Initially, so far we had one pair, this one right here, and this a coming in will form exactly two pairs. This is nothing but the count of the a's that we have so far. The moment we encounter a new a, what is the count of a that we have so far, which is 2. So this new a which is coming in is going to form two more pairs along with the current pairs that we currently have. So we already have one. So this new a coming in is going to form two more pairs, which is nothing but the current count of a's that we have. So we will do a +2 now, since it formed plus 2 more a's, and then again we have to update this count of a from 2 to 3. So now we have a 3 here. So now we have a 3 a's. Now let's say we found one more a. If we found one more a, this would mean that this new a coming in is going to form 3 more pairs, which is nothing but the current count of a's that we have. See, a is getting paired with this a is going to get paired with this a, then with this a, and then with this a. So basically whatever pairs that we have so far is fine, but this new a coming in is going to form 3 more pairs, which is nothing but the exact count of a that we have right now. So it's a +3. Now we have a total of 4 a's, and we update this count from 3 to 4. Now let's say I have one more a coming in. When this one more a comes in, and then you guessed it right, this is going to form another 4 more a's, 4 more pairs, and this a is going to get paired with this, with this, with this, and with this, 4 more a's, and then we'll have to later update this to a 5. So this is how the pairing count is happening, and this is how the hash mapping is helping us. This is exactly what we are doing. What we are doing is, in this case, this a value is nothing but this difference right here, the difference between the index that we currently at and the value at that index. We are finding that difference, storing it in the hash map. So the first time when we are at this place, which is 0, 1, which is like 0, I, and 1 is the value, find the difference, which is -1. -1 is not present in the hash map right now. We put it in the hash map, -1, and set its count to 1. We move forward. We now came to 1, 2. Now 1, 2 is the value which we are currently at, and if we do the difference, it's going to be 1 - 2, which is -1. Do we have a -1 in the hash map? Yes, we do. Here -1 is nothing but the a that we were discussing here. Now this -1 is going to form how many pairs? Exactly the count of -1 that we have right now in the hash map, which is 1. So we'll add +1 in our count. We added +1 in our count. So this made one single pair. Since we at this point we found a single pair, which is of 1, 2 and 0, 1. Basically this pair right here. This is our single pair, and it's and now we'll have to update this count from a 1 to a 2. Now again we move to the third index, which is 2, 3. We do the difference. We again find a -1. Now how many pairs will this -1 form with the remaining pairs that we have? So it's going to be exactly the count of -1 that we have, which is 2. So we do a +2 now, and update this count from 2 to 3. Then we move forward. We came at 3, 4. The difference between them is again -1, and this -1 is going to form again how many pairs? The current count of -1 in the hash map. We'll have to keep checking if that difference is there in the hash map or not. If it's there, update the count value, which is here, to the current value of that difference in the hash map. So the current value is 3, so we're going to do a +3, and later update this to a 4. Now we move forward, we came at 4 comma 5, right? I think this one got covered. So 4 comma 5 again is going to form 4 more pairs, and again update this to 5. So 1 plus 2 plus 3 plus 4. So we have 2 plus 3, 3 plus 6, 4, and then 10. So these are, so 10 is then nothing but the total number of good pairs that is forming, and so this is what we have, right? So this is nothing but the total number of good pairs, right? And if we are somehow able to know what is the total number of possible pairs, the total number of possible pairs, be it good or bad, and subtract the total number of good pairs, we can always find the number of bad pairs. In the second example, if you see the total number of the length of the array is 5. So if I ask you what will be the total number of pairs of I and j such that j is greater than I, will be nothing but 5 minus 4 multiplied with each other divided by 2, which is 10. So 10 are the total number of pairs that can be formed where j is greater than I. Just this value, j is greater than I, like are all possible pairs. And in all these possible pairs, if we subtract the total number of good pairs, which is again 10 in this case, that is why we are getting 0 as the total number of bad pairs. So what we are going to do is we are going to find this exact thing, which is the number of good pairs, and we already discussed how hash map is going to help us to find the number of good pairs. Then we also find the total number of good or total number of pairs that are possible. Let me also explain you how we are getting the total number of pairs equation as n into n minus 1, where n is nothing but the length of the array. So let's say I have an array of size, let's say 5, and the values are a, b, c, d and e. We are only allowed to pair values where I and j such that j is greater than I, meaning every time we are at a I, the j is going to be paired with the remaining remaining indexes in the forward. So that is why it's not a n cross n but a n cross n minus 1. I hope you are getting it, because this j is going to be running for the remaining values that I left. So let's say that currently my I is here, right? My I is at this place. So the possible values of j is going to range from these ranges, like inclusive of everything. Then I will move to this index. Then when I reaches here, then when I reach, originally I was here, then the possible value for j's to be paired with was these values right here. Then I moved to this one. When I moved here, the possible values of j's was this right here. Then I moved forward, the possible values of j was remaining these two. Then I moved again forward, then the possible values of j was all this. And then I moved up till here, then there was no possible pairings. So this is how the pairings is done. That is why it's a n cross n minus 1 by 2. This is a simple maths formula, and this is how we are going to get the total number of pairs which will be forming such that j is greater than I. Once we have all those pairs, and we already discussed how we are going to find the number of good pairs, from this total pairs, if we subtract the good pairs, we will get the total number of bad pairs. So this is how we are kind of flipping the equation and flipping the question to get to our resultant answer. So let's try to code this up now. So as I said, first what we need to do is we need to find the total number of pairs. So for that we are going to need n. N is nothing but the length of the nums. So total pairs is going to be nothing but this maths formula that we discussed, n minus 1 by 2, and we need to do a floor division, otherwise we will get decimal values. So this is the total number of pairs. Now we also need a hash map to find the total number of good pairs. We discussed what was the condition for good pairs, j minus nums j. So we're going to simply iterate for each index. You're going to keep iterating for each index, find the difference value, store it in the hash map, find the difference value, store in the hash map. If this difference value is present in the hash map, we're going to update our count, which is nothing but the number of good pairs, with the current value of the difference value which we just found in the hash map. Further down the line, we found a minus 1. If this minus 1 is in the hash map, how many pairs will this minus 1 is going to form? The current value of this minus 1 or the difference value which is present in the hash map. So it's a pretty simple kind of standard algorithm. It helps us to find the total number of pairs, and we did use this in a previous question that we solved before as well. So let's try to do this now. So we're going to iterate this entire nums array. So for r in range len of nums, we need to find the difference, which is nothing but r minus nums of r. This is the difference. We are looking for this difference value val in the hash map. So if val is in hash map, this difference value is nothing but r minus nums r. Consider this as a j. Now this j that we just found is gonna make pairs since this value is in the hash map, and how many pairs, let's store that in count. How many pairs is going to form? That will be nothing but the current value of this difference in the hash map. The current value of this difference value in the hash map, which we saw was initially 1 when we started with. So we updated with a +1, then later updated to the +1. Since we found this difference, and this difference is going to be added in the current value that we have. So regardless if we find this difference or not, we will always have to update this difference value in the hash map as well. So this is where the update part is happening. So when this loop terminates, this count value will be nothing but the total number of good pairs. So in the end, we just need to do this, return the total pairs that we have, total possible pairs that we have, minus the count value. Count is nothing but the good pairs. So this right here, total pairs minus the count, is going to give us the total number of bad pairs. So let's try to run this now. So as you can see, all the test cases are satisfying. Let's try to submit this. Yeah, as you can see, this is a pretty efficient solution and is beating all the test cases as well. And that was it for today, everyone. I'll see you in the next one. Like and subscribe.